forgot about it. Yeah, there's the first.
This area.
Open? Okay,
Yeah.
I'm sorry.
So if you were going to start the robot,
That actually sounds
then it's
all
gonna
of
think of it first.
I understand. That's fine.
Here, us.
Let's go.
How's Italy?
You're gonna need to
Good.
close
Really good.
You guys want extra stools to sit down?
Yes,
Stand.
it's fine.
Yeah.
We'll stand. Thank you.
It's at 6 o'clock, yes. So I'm just gonna wait until 6 o'clock and get started on
It's cool. It's good. Should we have like a countdown?
Or you can correct that part.
That's
Yeah.
true.
Yeah, it's 6 now. You guys can get started if you want.
All right, so 3, 2, 1. Okay. Yeah. Good evening, ladies and gentlemen. So we're from Triton Competitive Robotics. It's a student org at UC San Diego. So I don't know if you've heard, but UC San Diego and a lot of our corporate partners are trying to make San Diego, a world-class robotics hub. And as undergraduate students, we don't want to just stand there or sit there and take in lectures, do homework. We want to make robots, right? And one of the best ways to encourage innovation is to compete in competitions. So that's what we're doing, right? We're a student org focusing on entering robotics competitions all over the nation. And today we're here to talk about our BattleBots team. So, if you don't know what BattleBots is, or if you do, here's something to refresh your memory. We'll start at the beginning of the match.
You're like bringing.
Yeah, that's what I'm thinking.
This is a pretty one-sided match. Tombstone is actually one of the best BattleBots out there.
They won the whole thing. They won the whole competition.
Yeah. Well, I mean, not BattleBot Season 1. Actually, Byte Force won.
Well, that's true. At the very last challenge. Isn't it because their weapon broke?
Yeah, no, actually, because it couldn't damage Byte Force. Byte Force have a really strong drivetrain and a very heavy plating in the front, so the Tombstone weapon was just not effective. Yeah, it didn't do anything. Yeah, plus, like, when you have, 50 pounds spinning at an ungodly RPM, you tend to do damage to yourself as well. Oh, yeah. Alright, so this is our... If we can move to the next slide. Okay, cool. So, currently we have 7 people on our BattleBots team, but these are the people here. So, I guess I want you to meet all of them. Starting with me, I'm Jeffrey Wang. I'm Vice President of Triton Competitive Robotics. I'm a third-year mechanical engineering major, and, well, I recently got into this BattleBots fever, so we'll see how it goes.
I'm Alan Martinez. I'm a third-year computer engineer. I also don't have a lot of
robotics experience, but I know I can contribute a lot in programming a robot.
I'm Andy. I'm a first year mechanical engineering major. In high school, I was involved in First Robotics, which is a high school league, specifically FTC. So we built robots that just do various tasks. For example, last year's task was to pick up balls off the floor of various sizes and then score them into tubes. And I was team captain of our team, and I mainly worked on CAD and building.
Hi, my name is Jack. Like Andy, I was also participating first. I was in first team FRC 4930, and I was the sub-team captain for CADing and computer programming. I'm also a first-year student, and my major is computer science or computer engineering. I'm still deciding.
My name is Joshua Escobar. I am a third year at UCSD. Really excited to start BattleBots. In high school, I was vice president of our robotics club, and we competed in an underwater competition, so this is quite the transition. But I'm really excited, and I hope we can do some really awesome things.
Well, are you going to introduce the design?
Yeah. So far, we start this past week. We started working our design for possibly season 2 of BattleBots. So this is our robot so far. So in the front of our robot, we want a wedge with blades on top, and then in the sides, we're gonna have tank tread for our drivetrain.
Okay, we did a little animation
Yeah.
of the camera going around, but it's not working. So let's just go back to the previous slide.
Yeah, and then in the back here, we have a spinning roller, as well as a flamethrower at the side of the robot.
Yeah. So, yeah, flamethrower always get the audience going, and it's a really cool weapon. And if you stay near our robot for too long, there's a possibility of you just getting cooked, right? The internal wires or brains might be damaged. Also, it's a very good defense mechanism because, as a driver's instinct, you want to drive away from the flame, right? Even though it might not damage your robot, but you don't want to risk it. So having flames coming out of our side, our drivetrain, it can probably protect, the side and from robots from approaching. So yeah, that's the video again. So I'm gonna go over the weapons. So as Andy suggested, we put a wedge in the front because this is actually one of the most effective weapon in BattleBots. Because it's very, very hard to hit the wedge and actually do any damage to the robot. It's very hard to displace it or flip it over or do anything if you're hitting a wedge. Also, it's very easy to shovel under other robots, which is what a lot of team does. If you watch a lot of BattleBots, you realize that more than roughly 50% of the team does this. They implement some type of wedge or another. So you see some of the smaller bots, such as Shaman and Witch Doctor, they're literally just a wedge that's driving around. Yeah. Also, we put spinning blades here because just getting under a robot doesn't do much damage. Instead, we're going to have spinning blades, so we can potentially cut their drive base. That is our plan. Some robots like Bronco, they'll have flipping mechanism. They'll have, their wedge on the actuator, so when they get under, they can flip the other robot. But we have gone towards the cutting weapon-wise. And our secondary weapon, which is in the back, is the spinning blades, or the roller. We just call it the roller usually. We are hoping to make each blade out of titanium. It is not a cutting weapon. It is more of an impact weapon. This is effective. This used to be a very popular design. Like teams will get this up to something like 5,000-6,000 RPM, and it's a very fast spinning chunk of metal. And then anything that try to approach it will just get sent off flying. That's the idea behind the design. Also, this is a very effective anti-wedge weapon. So when the wedge try to get under here or try to shovel, our robot, the spinning blades can often just flip them over, get under the wedge. So, yeah, that's that. Next one is our flamethrower. So basically, we catted those propane tanks in here for the purpose of hosing propane gas because we're not allowed to use liquidized fuels. But we're planning on having flame coming out of the side of the drivetrain. So if a robot would try to grab us, which a lot of robots aim to do. Since Bite Force won the last season, we would expect a lot more grabbing robots. So if they were trying to grab us from the side, we'll just flame them. That's the idea. We can also implement some maybe flamethrowers in the front or in the back, but it's undecided so far. As you can see, this is a pretty rough model. It's the CAD of a prototype, so a lot of them is going to change. First, we're probably going to make it smaller, because right now it's roughly 50 inches long and then 30 inches wide. So it's huge. We're thinking about shrinking it, and also, the gas tanks need to be changed, because we're not sure what kind of gas tank we're going to put in there and then how big they have to be. So that's our flamethrower.
So you call this Hydra, and you've got the Trident. Everything's sort of water named.
Yes.
What's the connection to the land-based battlefield?
Well, there's actually a story behind our name. We were, a few of us got together and we were like, okay, we gotta have a name for our robot, right?
It was
And then,
yesterday night.
okay, I don't want to mention that, but okay.
But it was.
It was. So, we were trying to think of a naming convention for our robots and possibly for our future robots.
Mm-hmm.
And since we are trying, son of Poseidon, we're thinking of deep sea creatures or mythical creatures that go under the sea. And there was a robotics team before us had their robot named Kraken, which was our first choice. But, it wouldn't be very original if we did call this Kraken. And our secondary idea was Hydra. So.
You could kind of imagine it as our natural expansion of our undersea dominion to cover land.
Yeah, exactly.
It's just how awesome we truly are.
I thought you were going to drill a hole in it and push seawater into the bottom.
Maybe we'll add that in.
Well, but the rules do not allow water. That'd be pretty cool. I forgot to mention. So we decided to put tank treads on a robot instead of wheels, because it gives us better traction to the ground. Also, we can put strips of magnets on the tank treads, because the floor of the BattleBots, like the field, is made out of steel. So we can actually have this grip to the ground and potentially push others. It's actually one of the features the winning robot had. So it was actually kind of interesting, because in the final round of Season 1 BattleBot, Bite Force didn't have much of a weapon. Right? The winning robot, Bite Force, just had a wedge and a very powerful drivetrain and tank treads with magnets on it. And it literally just pushed Tombstone everywhere. And it didn't do anything with its weapons. It just pushed, and it won. So.
Well, yeah. So thank you so much. And if you have any thoughts or questions, feel free to.
Do you think it would be more or less energy efficient if you made those magnets on the treads electromagnets?
Exactly. Right. So what we were thinking of was, if they're electromagnetic, we get to basically control their strength. Right. So when like a tread is advancing on the ground, we activate it. When it's coming off, we deactivate it. So that's something we can look into potentially. There are some issues with that, namely like wiring to every single one of those magnets, and especially in conditions like BattleBots, where it's very likely in one match you'll have like hundreds of them just stripped off your treads.
There are also implications with regard to BattleBot's rules against any sort of weaponry that might interfere with an opponent's electronic systems. So we would have to be careful with that.
So what if you just put the electromagnets inside of the wheels instead of the treads?
It is possible, but it's a very hard idea to implement. We might work on that in the future. It's a very good idea.
If it gets flipped over, will it still run?
Yes, that is actually one of our features. Yes, we purposely we use 8-inch wheels, but the robot, I think, is 7.5 inches. And the 8-inch wheel does not include the tank treads. So if it's flipped upside down, it can still drive. And we purposely position this blade so it doesn't touch the ground when it gets flipped over. So a flipper would do no damage to us, basically. They can flip us all day long.
What did you decide on as far as motor type? You know, you've got DC, AC, brushless. With all of these legacy of robots, what did you all decide to use for your motor?
Right. So
Right.
we're still researching that. We're very likely going to use brushless motors. The only downside with those is it is somewhat expensive, but we're looking into it.
Yeah, for right now, we just put electric components from what we know, first robotics competitions. Those are the sim motors. And then
Obviously,
parts,
all of
but-
the control systems will be adapted once we make decisions for motors later on.
What kind of microcontroller did you use?
So far, we're still sort of exploring what in the way of microcontroller we would actually require. So we would only really need one if we wanted any sort of autonomous behavior or any sensors. Otherwise, an RC receiver could function as a logical operator for speed controllers. So it really depends on what sensors or autonomous ability we want the robot to have later on.
Yeah, an option would be probably the BeagleBone. It has a lot of I/O options.
We have a lot of options open.
Yeah, there's some kind of qualifying rounds or something like that. I mean, how do you know if you're gonna?
So a lot of the
Participate.
season 2 rules are still up in the air. There's going to be an application process, and after the application process, I'm guessing there'll be like non-televised qualifying rounds.
What will you do if you're flipped over sideways?
Well, the chances of that happening is very small.
We can make this convex, so we just fall down. Thank you.
Well, gravity would probably drop you with the weight of the
Yeah.
motor.
Since you mentioned how the wedge is such an effective kind of pseudo-defensive tool, have you thought about maybe incorporating that also on the sides?
Oh yeah. Oh yeah.
And
That's
that
a
would,
very
that
good
would kind of
point.
give you three at least of your dimensions being pretty much,
Yeah, it's
invincible in
covered.
terms of, because I can see like even if the if you have like a rotating weapon, kind of like in that previous competition, I mean, if they hit you sideways, I can see how I could just completely destroy the drivetrain on that one side. So if you had a wedge on there, it would at least sort of
Yeah, it would
deflect the
deflect it,
impact,
yeah.
and it wouldn't be just a direct perpendicular force. So if you kind of made that sort of those three sides, and then maybe that defensive weapon on the back being your only kind of rear weapon, maybe that would give you greater defense.
Switch the stainless steel skirt all the way around.
Kind of like a
well,
saucer.
yeah.
Actually,
Well, yeah.
not even a wedge,
Yeah.
but almost like an ellipsoid type cover
Yeah.
for it.
Well,
That would be
Maybe
even better.
easier to flip over.
The CAD drawings were primarily to show what we had come up with so far in terms of chassis, drivetrain, and weapons. Body modifications can always be added on in terms of protection. Obviously, a key component of that will be trying to deflect the force of any sort of impact weapons in the
Well, I
phone.
never actually seen that, but now as you're mentioning it, I'm
Yeah.
thinking, well, why not incorporate that not just in the front, but also laterally, and that would give you protection on side
Yeah, on three
weapons.
sides.
I don't
In
know, just a
BattleBot
thought.
Season 1, there was actually a pyramid design. The entire robot is a
I
pyramid.
kind of saw it, but it seems like your center of gravity and everything would just really be kind of weird. I don't know.
That's true. It's possible, but we can always redistribute the weight to try to get it.
Anyway, just a thought that can't.
Even if you didn't put a big wedge out there, you could put like a leaf spring so that it wouldn't be damaged. You'd be shoved away, but you wouldn't be, absorb all that energy.
What about some kind of entanglement device, or if the rules don't allow that, at least some component of this that would break away and get caught in that tombstone blade?
Oh,
There are actually rules against both of those. You're not allowed to have weapons or shrapnel type weapons that would break off for the sole purpose of damaging an opponent's body. There's also rules against entanglement. Like you're only allowed to hold them for like 15 seconds.
15 seconds.
Yeah, before you're forced to let go.
But it's actually a pretty cool idea. In fact, when we were talking about the various design components, we were actually thinking, hey, we're UCSD students, let's make something maybe bio-inspired. We'd have something like a gecko that would have a sacrificial tail. But yeah, there are rules.
Have you considered putting like a claw arm on the top to drag your opponents into the spinning blades?
We have come up with thoughts about it, but first it's a very complex piece of machinery, and also, it's very easy to break off. to a lot of the weapons, and yeah, we're trying to keep this very simple and effective. A robotics arm would definitely help if it's implemented correctly, but it's a very hard idea to implement.
And with rules against holding, that complicates it, like the actual effectiveness of the arm as well. So for this design, one thing we're hoping for is that the wedge with the blades could potentially push an opponent over our bot and onto the spinning cylinder in the rear, or vice versa. So flipping the opponent's bots and smashing them around is sort of the goal.
Also, this robot should be around 220 to 250 pounds. So a lot of grabbers would grab onto the robot and try to lift them, but somehow lift themselves up. So, when you have equal weight robots, it's very hard to actually grab onto the other robot and make it an effective way of disablement.
From your experience of studying bots from the
Of watching
past,
television.
do you have any idea how much current, how much battery you have to run something this big and heavy? I mean,
We have some experience from FIRST Robotics,
Yeah. I'm just curious how much.
but we only have to have this thing operate for 3 minutes. So basically, we're looking at small size batteries.
A lot of
other than that,
A lot of it will depend on what kind of motors they want.
Right.
And the rules for the competition state that, or at least last year's rules, assuming that they're similar this year, that max voltage throughout the robot can be 270 volts. Although anything above 48, you have to demonstrate specifically that you know what you're doing for safety
yourself.
reasons. Yeah. So,
yes.
I think I've noticed that sometimes bots tend to catch fire, probably on their insides, like before the match starts. It's like they can't even move. You just see smoke coming out of the robots. Do you know what causes that?
Probably short wire.
Yeah.
Outbound short wire.
Power management is also a big thing. Like a lot of teams are using lithium polymer batteries, and they have a tendency to swell, for example, under a large current draw. And compared to other types of batteries, can be relatively unstable. So, like protecting them from impact is a big thing, and allowing them for swelling and that sort of thing.
Also, wire management is a big thing in this. We are creating a layer just for wire management, so it's not going to be at the main level.
Are you going to make a printed circuit board to get rid of some of the hand wiring joints?
So we're still in the process of exploring power management and electronic board configurations. I was going over this weekend, and as appealing as it is to have like a printed board to get rid of wires, one thing that a lot of teams face is components dying throughout the competition. And so for modularity, a lot of times a printed circuit board tends to be not as efficient and costs a lot.
A single point of failure could take you out.
Yeah, exactly. Versus a single motor driver, you can just swap that out really easily. It's just connected by wires.
For the next round.
Exactly. Yeah.
So you should consider thermal management.
Yes, ventilation and thermal management. We're still trying to work this model out, but so far, I don't think thermal management is a crucial point in a lot of the BattleBot matches, because we only have to keep this running for 3 minutes, and if it's not under flame, usually it's not going to exceed the maximum heat capacity.
Well, you're gonna create flame yourself, so
That's
you're
true.
gonna be heating yourself up in the process. How much capacity do you have in those flame tanks?
We do not have the specs on that, but
They can reload them every 3 minutes.
yeah, we have to keep them going for 3 minutes. That's our goal.
I noticed that in watching this last season that the flamers just put a lot of flame out, but it wasn't focused in any way. But if you put jets on the side of that, where you could intensify the damage that the flame could do. That.
There are rules about the maximum pressure we're allowed in a tank, so I think that might be why the flames are not going as far.
As well as rules against certain gases. So like one thing you might think of is like an oxyacetylene torch on the
Yeah.
side. Like that would be really awesome. But we're specifically not allowed to use oxygen in there. So it's just butane and propane.
Because the flames aren't going to really get that hot.
No, yeah. But assuming the BattleBot performs well, flames will go a long way in getting you televised. So name recognition.
Since you're sort of aquatic, sort of oriented, have you considered some kind of a harpoon type of weapon? Is that allowed or
There are rules against entanglements, but
not tied, but maybe some kind of like a trident thing that would just kind of be, you know.
we actually thought about it. We thought about instead of putting like saw blades, we thought about
Well,
putting
in
a
addition to,
poker.
yeah, in addition to, I mean, I
Sort
like
of
the idea of
pneumatic
your
spear.
cutting, but some kind of like a impact kind of
with an
titanium
actuator
tipped
behind it. Yeah.
that would actually penetrate into the opponent's body, and then that could conceivably disable him. I mean, and have some kind of like a trident thing that would come out and kind of poke holes in your opponent.
So,
Something
like-
like that.
Yeah.
As
So
long as you do more damage to them than you do yourself.
right.
Well,
Watching last season, it seemed that Tombstone pretty much destroyed every single opponent he came up with. I mean, just like if you any match with Tombstone, it's like, well, that robot's going to be destroyed. So, what made you think? I mean, the one that won was, I guess, the one with the magnets on the bottom.
Yeah.
What you're saying. But it just seems like even I feel like that match could have gone either way. I mean, they had to switch out the front to like that big heavy metal plate to defend against Tombstone.
Didn't one of Tombstone's batteries burn up?
Oh yeah, that happened too.
I think
like,
that was the reason why.
Well,
Yeah, and then he
got
couldn't even move.
knocked up on its side, and that big, all that inertia went into the floor.
Oh,
It
okay.
broke the mechanism.
Oh.
That was another.
I feel like on a separate round the thing broke, and then
Yeah.
I can't remember all the details.
Uh-huh.
But
it
anyway,
was a separate
my
round.
point is, I guess that it seems like such an effective design, and I think there was another kinetic robot that did pretty well too. Like it just seems
Ice
like it's
Wave,
such.
right?
I'm not sure, but it just seems like so effective. Like
Yes.
increase your. I mean, it's simple too.
We thought about implementing a tombstone on the back instead of the roller, but that would be so unoriginal. Because they have a huge fan base and everybody recognizes Tombstone. When they see the robot, if we have something like that, they'll see it's a Tombstone. But I think the reason why we analyzed the video as well, but I think the reason why it wasn't Icewave, why Bite Force won is because first it have a very strong plating, so I would assume it's something like 1/4-inch steel. You can have a really strong spinning piece of metal, but I don't think it's gonna completely penetrate or destroy a 1/4-inch steel plate. The second thing is they have firm grasp to the ground. So we're planning on putting magnets along the tank treads for that purpose. So our hope is we can stand our ground if something like Tombstone or Icewave hit us, and if they hit us and we stand our ground, there's a huge chance that they go offline by Newton's third law, and then they cause damage to themselves as they hit the ground with the weapon. I think that's what happened during the match between Tombstone and Biforce. Tombstone hit Biforce, but Tombstone went off instead of Biforce.
Yeah, it broke itself.
Yeah, it broke itself, and then it went bouncing around.
Is there a constraint on how much these things can cost, or can you throw as much money as one can afford?
I didn't see any rules about cost.
There's no constraint on cost. Like,
Their sponsors deal with that.
I mean,
How much do you expect to pay for this? Like, do you have any rough estimates of how much this would cost to build?
so cost for building would probably be around 10K. Yeah. Which means
Speaking of which, do you guys have sponsors, or how are you going to fund that?
so we've been trying to raise money through corporate sponsorships. We've only just started the whole sponsorship process. Currently, we have like some small private donation, some small sponsorship by Microsoft, but we're still pursuing a bunch of other corporate sponsorships.
You should put that baseball cap that Trump uses. Right? Trump said, "Hey, we'll advertise it." You'll throw in a couple $100 million.
He's not going to do that until they win.
I wouldn't want to be associated with the
Yeah,
losing
exactly.
team, would I?
It's just not Trump.
Could be a pretty fancy
yeah.
bot.
How do you pursue corporate sponsorships?
we have some experience with first sponsorships. Basically, we email them, we get in contact with them, we talk to them, and then maybe bring our CAD model, our budget, and explain to them what we're doing and what our goal is and why they should sponsor us.
Okay.
For first robotics, we usually have polycarbonate panels that have sponsor logos on them. basically we talk to them and explain to them what we're doing.
And so for like a college organization, it's a little bit different because we can offer some, corporate sponsors a little bit more. So a little bit more publicity, a little bit more on the recruiting angle. We have around 150 students in our organization. That's a lot of talent that companies can tap into if they choose to sponsor us.
So you haven't approached any of the large sort of pseudo robotic related, even
Qualcomm.
Well, I wouldn't approach Qualcomm right now. I don't think they've just kind of downgraded their robotics sort of influence a little bit. But I mean, somebody like Northrop Grumman
Right.
or even General Atomics would be maybe some people that still have a lot of government cash coming in. They might be interested in sponsoring.
Right.
I mean, you try Qualcomm, but I understand they just canceled their robotics accelerator program. Did you hear about that?
Yeah.
Well, I mean,
Is that the one Techstars was going around?
Yeah.
Really?
Yeah.
So for FIRST Robotics, for my team at least, the largest contributors were Autodesk because we use Autodesk Inventor for all the CADing, and the second one is NASA. NASA gave us a lot of money, so we're gonna try to approach them.
What is the weight limit?
250 pounds.
Okay. And what about, is anybody using something like maybe a 2-inch thick rubber bumper around it? So that, I mean, if that, because that would give you a lot of give. That I've seen the blade on that Tombstone up close. I think that thing weighs, I think maybe 50 pounds. It's really heavy.
And at that speed, it's about
Yeah.
10,000-pound hit. Hits you.
That's a very cool thought because I haven't seen any team implement the rubber idea, and it's not gonna cost. I mean, it's not gonna weigh that much, anyways.
Yeah, it's definitely a very cool idea. And in fact, like our advisor works on soft robotics. He's a professor at UCSD, so it's something that we're definitely looking into.
Is there any rules about jumping? You have
can
to stay on the floor?
Well, you can jump. A lot of robots actually flip themselves over by jumping.
Yeah.
Basically.
What kind of protective mechanisms do you have for the? Are you considering for the top?
Sorry.
For the top, I mean.
There's gonna be a piece of cover plate.
And it won't necessarily be flat. I mean, we would try to come up with some sort of design to deflect the force of an opponent's attack, along with some sort of internal cushioning system. One thing that I also noticed over the weekend with shred drivetrains in particular, suspension is really, really important.
Do you have any plans to have like a last resort? As in, if they beat up most of your robot, but you have this special shielded part to use your weight to damage the robots to just try to win early.
We're hoping that the drivetrain will be fairly robust. It always fails if our weapons are somehow, disabled. The arena has a lot of built-in obstacles and weapons, so we can push them into the built-in obstacles in the arena.
One thing I was reading on the Tesla automobile, the reason why it's one of the most safe on the is because it's designed to actually crumple at a certain rate, and they have, I think it's sort of like a shock absorber. I mean, it's like a telescoping mechanism. So that would be another alternative to absorb, brunt force, especially if you could reposition it. If they were extended out, if you got hammered back, you could sort of like an air shock or something.
Like a vibration deafening system.
Yeah.
And maybe we can implement it on the side plate or even the front panel.
Yeah.
Are you guys looking for additional team members?
Yes, but for the designing process, we are basically just keeping it between the few of us. But yeah, we're definitely looking for more people to join us.
Yeah, we definitely welcome any community involvement. If you know of any like CNC places you can fabricate things, that would be really helpful.
No, I would assume the university would have a big fab shop somewhere. Not true?
They do. It's also very much booked up by all of the research that's going on.
Have you considered some 3D metal printing
Actually,
for your components?
so not metal printing per se, but we're looking at Mark Forge. They print nylon with carbon fibers.
The carbon
In,
fibers.
yeah, carbon fibers in the nylon, and
I
that
see.
actually makes it pretty strong, probably like aluminum.
Out of an extruder?
Yeah.
A
So-
regular 3D printer extruder? Or?
Yeah, so it's two extruders. So one lays the nylon and one lays the carbon fiber.
Well, I know your UCSD has the 3D printed rocket engine, which is
So-
metal, and that's been successful. I mean, they can fire it; it works perfectly well. So for any component parts that might reduce cost, I believe it's cheaper than milling.
Their 3D printed rocket was not cheaper than milling. It's actually
wasn't?
Yeah,
Oh, okay.
quite significantly more expensive, and they did it at General Atomics. So, not UCSD itself doesn't really have the sintering capacities to do that. One thing about the 3D printed rocket is they can make designs you can't really mill. So that was their advantage of a 3D printed rocket.
So are you familiar with open source MakerLab, MakerPlace, and FabLab?
So I've heard of both. Dan Hendrick.
He's got a large shop. Space. He's got a lot of space.
Definitely. If does he usually come to the meeting? No.
He's too busy running that place.
We can probably like drop by sometime and talk with him.
He's open at 6 in the evening. Very late. It's at night.
So I can fix that.
He's always there.
Takes about an hour to get up.
Where's that?
Fix
Good
that.
timing for us.
Buried.
Downtown, there's FabLab.
Maureen upstairs, there's
Maker
a
Place
Maker
is also
Place.
another alternative.
Is
And then
Nucamp?
there's membership driven.
Is Nucamp still alive? Is that the one at Gillespie Field?
I can introduce
Yeah,
to
definitely
those
if you
people
can intro
if
us.
you need it.
That'd be helpful.
I'm waiting for somebody to do a carbon fiber one because it's actually stronger than steel. It's a lot lighter. Bigger motors, batteries.
Yeah, if quantum drops like $500,000.
But they put up the price.
Yeah, for now, for material wise, we're basically looking at aluminum, titanium, and steel. That's the three we're looking at.
What's your deadlines? When you have to have the
So tentative deadlines that BattleBots told us was applications sometime December, and then start of the season sometime March. So it's pretty tight.
Do you think $10,000 is gonna like include the cost of remaking things that get broken?
We are making a lot of plates out of steel because most of the BattleBot places have steel welding equipment. We are trying to make a lot of parts modular so we can just replace them instead of having them remade. So in order to keep the cost down. But I think $10,000.
10K should cover like a couple of spares. We don't go crazy with the titanium.
That is true. We're only implementing titanium with the blades and the roller blades.
So, Jeff was telling me that the story portion is really important too. To get into BattleBots, what's your story?
We're still
Working on that.
hashing that out, right? But something we're thinking of is really selling the UCSD association, right, that we have. So maybe more scientific or high tech looking. I actually went to the Contextual Robotics Forum, and they had this neural headset which they're using to control drones. So something like that would be very, very
different designs that kind of play on that could help us with our backstory of being university students.
Maybe one of you could cut off their leg and lost my leg.
What's your deadline?
Your design is already pretty much down, right? It's going to be this flat wedge thing.
Well, this is actually just a prototype. We actually threw this together in 3 to 4 days. So yeah, we're going to be changing this. We might even remodel this. First, we have to shrink it down to a smaller size, and we're going to change the weapon system and adjust the spacing for the electronics and adjust the space for the propane tank and the motors and everything.
I mean, the thing is that if you want to tell a story and it's related to UCSD, you need to look at these old Roman gladiators with the trident and the net. Those would be expendable. And the real weapons need to
Get
look
a
like
graphic artist on your staff just to see what they come up with.
We were thinking about CNC milling the patterns on like the steel plates.
But that's really so. This is really just like our framework, right? We have our drivetrain down, all the components that we know we'll need, and so something BattleBots emphasized as well was modularity. They like modular weapons, things you can swap out. So like, say we wanted our trident, we could potentially swap out this wedge for a trident, as long as we're not facing Tombstone.
I think you have to assume somebody's going to copy Tombstone. It's so effective. So you can't throw shrapnel, but can you throw goo? Can you slime? But, all you have to do is throw a wad of taffy and let that
Why don't you just have like some kite string and just let it go? I mean,
there are rules against entanglement devices.
But if you're not actually entangled, you're not holding on to it, and it's not entangled.
We say that like that was loose wire that came out of our robot accidentally.
But I mean, you're not. That's what I'm saying. Like if there's got this, some kind of spinning hammer, and they're just wrapping up the kite string.
We are countering the problem by implementing strong footing with magnetic tank treads and strong plating, 1/4-inch steel plating.
Yeah,
that's.
You could put a circle cutter in the bottom and drill a little hole in the floor, and then put a little stud there, and then drive away from it. You just keep that between you and Tombstone.
I suspect, since last year's winter, had the design with the treads and the magnets and the thing, that there'd be a lot of people all with your same idea. And then I also suspect that people would specifically design against that, assuming that people would do that. Like, I don't know. I mean, what do you think? I mean, like, what do you think about that? I don't know. Just something about it.
Well, we could suspect that people are making designs to counter this, and they counter that design. But then there might be people that counter that.
Could be like Princess Bride.
I mean, if everybody's gonna make the same design, I would imagine the BattleBots, however their selection process is probably gonna be like, okay, well, we can only have like a couple of people who have the same designs.
I mean, I imagine like that girl that had the brain on her BattleBot. Even I don't know how I forget what like weapons that thing had, but it seemed like I don't know. It's just like it was there because it looked cool,
right? Yeah,
and it got demolished.
Yeah, the BattleBot selection process actually includes a lot of style. They don't want a very compacted and effective robot. They want something that looks cool.
Right.
So we thought about how we might.
Well, how come it's so big now?
We thought about how we might make this.
You said you wanted to shrink it, didn't you? Well, that's what we're doing. We're helping you out.
So in order to make this sort of exceptional, a lot of teams make their robot looks like either monsters or destroyers of some kind. We are, thinking of going a different route, but right now we're still working on the theme of our robot.
What if you had, say, an axle going to the very center of the robot, and you had a wheel around it, to where, something like Tombstone, there would be no sharp edge. So anywhere it would hit, it would just,
It's a 360 weapon.
Yeah, it would be like a completely round, say, rubber rubber padded wheel or something.
A
So it
few
would hit.
robots implemented that idea actually. Ice Wave had like tombstone on top. Tombstone on top. The spinning blades on top that that have its diameter, longer than the robot, so it will protect the body of the robot. But it was a very successful robot, but it didn't win. I think the reason why Tombstone is so successful is because first the plate is really heavy, and it's not, I'm not sure because if you put it on top, I think its center of mass and everything is gonna be off, and if it hits something, it might rip the top parts off because it's such a huge piece of metal and it's moving at such a huge momentum. And also we thought about putting this bandsaw around, make like a UFO design. But one thing about BattleBots is blades rarely cut through steel during the match. Robots are usually always damaged by impact weapons, whether it is the Tombstone rotating huge piece of metal or Ice Wave rotating, basically doing the same thing. So I don't think cutting through things would be a very effective weapon.
Yeah, you have cutting tools on your.
Right, but this is aimed for the drive base, for the base plate, which might be, poorly protected.
And even the roller, its main function isn't necessarily to cut into the opponent's robot. It's to flip them around, to smack them with the rather dull blades that are on it. And we were actually discussing in the car too that we might implement some means of actuating the roller to sort of smash it on top of an opponent's robot. So I mean, the design's constantly evolving.
Has anybody worked out the physics of how much inertia really is in Tombstone, where you could have a sacrificial edge that would take the impact and absorb it and then just jam it to where it would all go against that axle in the middle or throw the other robot, but it wouldn't cause a damage other than absorbing it. Because you're only going to run for 3 minutes, because you could always put another absorption pack on the sides.
Well, if we absorb it to lessen our impact, the impact on Tombstone is also going to be lessened, right?
Yeah, but if you could stop it, one of the things about Tombstone is that one of the matches, if they could get across the floor fast enough before it built up the inertia, that thing was ineffective. Right? It would hit them, but it wouldn't hurt them. So if you could just absorb it and have them have to start over again, you'd have a time advantage to get in there.
Yeah. So I was thinking, what if you had a skirt around the robot with like a really gentle curve that was made to kind of get Tombstone's spinning blade to kind of ramp up on one side so that it's kind of forced to flip to one side, and that the its own force would smack against the ground and maybe knock its bar off, because like I've seen that happen to Tombstone before. It's like as soon as it flips onto its side and the bar breaks, it's over for Tombstone. So
yeah, that went back to the 3-side wedge design, which is something that we might implement because it's a very good idea. Also, the point this gentleman brought up also goes back to one of the previous designs, the huge vibration dampeners on the side, so it will effectively stop the Tombstone blade, which is also a very probable design.
Well, instead of a flat blade in front, if you had a crown in the middle, then anything that would hit it from the front would rise up the ramp. So you would give an automatic flip effect if you could survive the impact.
That's the 3-side wedge design. And literally BattleBot.
What if you have this special pusher underneath it? This way, its design would be to, if somebody were using blades, its design would be to make the blades go out of place and make the robot cut itself.
Are you talking about like a flipper that goes underneath the robot?
Like, it would push the shaft and make it so that the blades would be sideways, thereby cutting the robot itself.
That's too strong. So he has a neat idea. If a little bit, you have another mechanical part. Once the component's lifted, if you could go under your wedge and affect their traction, get to their wheels.
I kind of sort of like the Bronco design, that have a wedge that get underneath Tombstone.
Yeah, well, that wedge, if you start to get a lift, now you've got a space underneath the robot,
Yeah.
and then you have another mechanism comes from behind. It goes under your front wedge
Oh yeah,
and gets taxed.
extendable front wedge.
Yeah, and tax their drive.
I was
Maybe a
actually
trend
I was actually curious as to when you have such a large mass in the Tombstone type weapon, what kind of gyroscopic action would you get out of that? It seems like you'd have a tremendous amount of gyroscopic effect on a massive rotating weapon like
That's
that.
one of the problems of lifting it.
Well, obviously it got lifted and
It
flipped
doesn't want
over.
to change out of that plane.
You would think not.
direction of the blades goes in, you can actually design your robot to be more effective. One with
Yeah, you want
Because
the
that
wedge
would
flip
provide
in a certain
a
direction.
tremendous amount, as you were saying, a tremendous amount of resistance to a lateral sort of axis rotation, and would maybe increase stability to keep it level.
We can have
So-
modular armors that you can be swapped out just for Tombstone.
I was just wondering.
Several armors.
Yeah.
I was just wondering if anybody had incorporated that sort of mass gyroscopic action in terms of either stability or maneuverability of the robots. I don't know. It's just kind of seems like you'd have a significant amount of that. But
To take advantage of what you're saying, you would never want to attack frontal. You'd want to attack from the corner, mainly on the corner where that gyroscopic effect would tend to flip it over.
yeah, it would be a 90
Yeah, if
degrees
you
or
lift
something.
that
Yeah.
corner, the gyroscopic effect would try to flip it. If you came the other way, it would stop you dead.
Well, anyway, I was just trying to see if anybody had actually implemented that particular effect in terms of some type of advantage. But as far as
A lot of people didn't plan for Tombstone very well.
well, it was
until their robot get ripped to pieces.
It was sitting out there so far forward of what I would guess the center of gravity of the whole thing was. I'm not sure if that would affect its stability, but if you had it like towards the center of the robot, where the actual center would be almost the axis of the gyroscopic action, that might actually enhance stability for not having it flip over. But I'm not sure if that would be possible to implement.
You guys had considered possible costumes for yourselves? Have you
There
practiced
must be
your
team shirts, yes.
tough guy poses that you do for,
Oh yeah, we need to work on that.
Well, given our
the
backstories, it might be more like they're
Ah.
guys.
well, that's everybody that participates in that.
Well, bring some girls in. They could be dressed up like mermaids.
Yeah, since the theme is deep sea, we'll have mermaids and mermen.
You know, one thing
There
I
you go.
wonder about is I see the guys struggling trying to drive these things. It seems like that they really have a difficulty turning them in the direction they want them to go in. What's any advancement in that? I mean, I guess you're using like a Spectrum RC controller.
Yeah.
So
But,
last year, BattleBots actually required a digital Spectrum system to sort of handle any interference you might receive during the games. So something along those lines. For easiest implementation of that is your 2.4 gigahertz RC airplane controllers. But I mean, there are other options. It's just a lot more work to get them implemented in terms of coding and everything, and even hardware design.
Also, this is just gonna be standard tank drive, but I do not understand why some robots seems like they struggle to maneuver themselves.
Well, like Tombstone, right? It's very hard to rotate its body because of all of that rotational inertia. It
That's
has.
true.
Different.
That was one of the
Different
reasons we
robots
decided to go for the roller as well, too. So
Well, isn't that also a operator perspective? I mean, if the robot's going away from you, you want to turn right. You know you want to go right, but when it's coming at you, you want it to go that way. But you have to kind of
Yeah, you
change
gotta
your
reverse
perception.
it.
And that's
where you could use a computer. 'Cause
well, yeah, but
you can-
but I
you
don't.
can
None of
move
these
that
things
around.
use computers. They're all strictly RC. I don't think there's any autonomous capability in any of these BattleBots, are there? At least I haven't seen any.
People
Well,
that
but
fly
you
airplanes
could.
figure it out.
Well, yeah, but I mean that takes
Practice.
a lot of practice to get that change in perspective. You know, when you have like changing directions and now you cross, you know, you're where you would normally point and from your frame of reference and the frame of reference of your control device. So
You could put a
I think that's
camera on
no.
the
I think that
car.
just means that that's a lot of the problem. You know, when these robots are going at an oblique angle or towards the control RC, you know, operator, it just you know, in the instantaneous moment, your reflex might be to go one direction. It's actually going to go the opposite direction. So I don't know how you could solve that. But
One practice, right?
Yeah, practice.
a lot of practice.
But one of the crazy ideas we had was we mount a stereo camera on the robot.
You mean like an FOB type of thing,
Right.
or
And then you would have an Oculus. The driver
Yes,
would have an
Oculus
Oculus
Rift.
Rift.
That might be scary.
Oh yeah, it'd be scary. It could also be a lot of fun.
It would be a lot of fun. That's for sure.
puking in your.
so first person. So he would be wearing the operator would be wearing some kind of a
Yes,
like these
Oculus Rift. Virtual reality.
virtual
sets.
reality type goggles, and then he would operate it from that point of view.
You see blades coming directly at you.
You get so sick.
Yeah, we would solve that problem. But boy, I don't know. That'd be interesting to see implemented, especially because then you lose that perspective of what's surrounding and what's coming at you from a
Just
different
create a
angle.
new form of interrogation technique.
Right. You'd probably drive over one of those saw blades in the middle of the floor and not know it.
No, I think the driver would be a little bit more invested in the safety of the robot.
Yeah, also practice tend to solve a lot of those issues. For FRC drive teams, we practice like 2 to 3 hours, pretty much every meeting, to get the techniques down. So.
I would just buy a bunch of cheap RC cars and drive them around. Get used to
Yeah.
controlling them.
Getting used to controlling them, just like we're doing research by watching TV.
But that's, I mean, it's a similar controlling mechanism and similar stuff. So. We have to configure them to tank drive. Tank drive though.
On the floor of the arena, you said it was made out of
Steel.
Stainless steel.
Not sure what type of material.
It's magnetic.
Yeah.
Well, even stainless steel is magnetic, but it's substantially less so than just plate steel or iron or soft iron would be the ideal surface, and I'm sure that's not what they're using. But have you considered that in terms of the effectiveness of your magnets on the
Our
material?
magnet design is based on Biforce, since it was very effective for them. I don't think they're going to change the flooring material, so it could be very effective for us as well.
Was that confirmed that it was actually that effective, or is it just assumed that it was?
We assumed, but when you see a huge spinning blade hitting, the robot and it's not going out flying and it's not even really moving, we kind of, dig down for the reason, and then we thought that it might be for.
Are you planning on testing out the concept to see if it actually does provide that much greater?
Well, we can measure the amount of grips, but I don't think we're going to hit our robot with a tombstone weapon.
No, I don't mean in terms of destructive testing, but something along those lines, trying to find the same material and see just exactly what kind of magnetic attractive force you're going to develop on that particular type of steel.
Yeah.
Because like I said, if it's stainless steel, that's not very magnetic in terms of, sort of capacity or...
Yeah, I think we'll definitely test the...
So you would have to have some
against
kind
the
of access to the actual flooring material to be able to, or at least have them let you know what exactly it is for you to be able to duplicate the actual attractive force that you would experience. Because like I said, if it's stainless steel, it's not going to be very strong. But you can test that out at home with a magnet.
Well, one thing about Biforce is once it implements magnets, it's pretty much giving up on the rubber, the rubber surface, right? It's really just magnets holding the robot to the ground. So if it's not very, if the floor is not very magnetic, they will probably be sliding because by implementing magnets, they're really giving up the rubber surface of their tank treads. So that's our basic assumption, but I think we'll definitely test it.
But you wouldn't have very much traction even on steel. So do they coat that as with some kind of a surface or some kind of a more adhesive surface, like some kind of a rubber coating or something, or is it just plain metal that's on the surface? Do you know?
We're not very sure the exact material of the floor, but we're gonna definitely do more research
Or
on
if
it.
it's coated with anything that would
Yeah, it might be
add
coated with
traction, because I don't see those robots sliding around much, and it seems that if it were just metal, they would. I don't care if you had rubber or what. It's not going to grip very well on metal.
That's true.
There's a lot of big rubber tires used in them.
Yeah.
But that maneuverability seems like a critical Achilles heel. Has anybody used the little wheels that go sideways?
Omni wheels?
Omni
Definitely. Slide
at a
around.
heavy enough of a quality to where that when you go this way, you could go that way instantly, instead of having to go stop and go, this maneuverability seems very poor on these.
Yeah, it's a balance that we have to, we have to weigh both sides. We don't want to get pushed around. That's one big no against using Omni wheels, because we slide around everywhere with Omni wheels.
If someone uses a design similar to the Nightmare, why don't you send out a magnet from the robot slowing down the spinner because it's being attracted to that magnet, and make the robot out of a non-magnetic material. This way the robot will be attracted to it and they won't have as much force and speed.
Well, first, we don't know what material the spinning blade is made out of. It might not be very magnetic. Secondly, it will have to be a very strong magnet to hold the blade in place.
I'm pretty sure.
Neodymium, strongest magnet.
I'm pretty sure that the guy who made the robot said it was made out of aluminum.
So it's not magnetic.
Let's see. Also, I'm pretty sure his robot used to be called. Actually, I know his robot used to be called Last Rites. Do you know when it changed?
Yeah, so Last Rites was the name he used to compete in Robo Games, and then when they announced the first season of BattleBots, he entered it as Tombstone.
Is there any way you could take advantage of creating a high voltage from that piece of steel spinning around, you having a coil with some way to discharge through
So the rules
electricity
say
through the robot?
basically that we can only have up to 220 volts.
220 volts.
Yeah. You wouldn't have to have any voltage on your side. You just have a coil.
Well, no, yeah,
that
the
build
main
up
issue
a
is,
voltage from that spinning.
in addition to just voltage requirements, they have rules against any form of electronic discharge that could potentially interfere with an opponent's
It sounds like
electronic
the
system.
rules was written by.
They play the rules very well.
So maybe you ought to get our political partner to go change the rules.
Maybe we could just put put the list of rules on the screen so that everybody can see it.
It's a huge list.
Oh, really?
It's 6 pages.
I mean, we
very
saw the
small
Google
font.
Drive.
Because I thought it was all on one page. It used to be no flame weapons, no energy weapons, no untethered projectiles, no entanglement, no shrapnel, no liquids, no solvents, anything like that. So,
Projectiles are actually allowed.
well, it said no untethered projectiles.
I think untethered projectiles are allowed.
If it's classified as a minibot.
Yeah, you can launch a mini-bot.
But no bullets or anything like that. 'Cause it's,
No explosives powering it. We can only use spring, gas,
You can have
and
air
catapults.
So if you want like BB guns, just
It's not gonna work, but it's pretty cool if we have
Alright, a couple last questions.
I was gonna ask if you considered mini-bots, because this is the first time I saw them when I watched that season.
Yeah, Shaman had Witch Doctor, or the other way around, and Warrior Clans was a group of 3 robots that just run around. This is a prototype design, so we don't know how much it's gonna weigh, because all 3 robots have to weigh under 250 pounds. We have to make a decision whether we want to make a huge robot that's really steady and powerful, or we make a bunch of small robots. And
Oh, I just thought of something. That idea of a stud drilled into the floor, and then you get in between. You could have your little robot run off and magnetize itself to the floor.
Yes,
and just be a cylinder.
So we can't damage the...
Exactly.
With a big coil, and it just sucks to the floor, and then you stay on one side of it.
Yeah, when someone brought up having, drill through the floor, of course they're not allowed to damage the arena, one of the robots got in trouble for it because they had a huge hammer and they missed, so they put a huge dent on the floor.
magnet would hold it.
Yeah, we can actually put a magnet in the center, a electric magnet, and then have it raise down to the floor, and then just hold onto the floor.
Would just like maybe a giant suction cup. That'd be a lot lighter, and it would. It might give you actually better
experience with suction cups.
Well, I mean, octopus. Come on, you guys are aquatic, right? I mean, the octopus uses its tentacles as suction cups to attack its prey and grab it. And to me, it seems like it would be lighter, and it might even give you substantially greater attachment force than a magnet. I mean, if you had like a silicone type suction cup that would just kind of like pull up on the floor.
That's true.
That could actually anchor you much more rigidly.
I'm not familiar with the releasing mechanism on the other hand.
You let air in. There's a suction in the cup. You breathe in air. It's off, man. It's not gonna be permanently attached. The magnetic force might be difficult for you to come in and out. It's hard to control. This is an electromagnet. I'm not sure what kind of your electric power usage might be prohibitive in terms of motor and everything else with the other consumption. Whereas some kind of like a vacuum cylinder, we could just apply it and then just a valve that just lets air in and boom, off you go. That might be something that you might be able to use rather than because I'm sure you can't drill into the floor. I don't think they're going to let you do that.
That's why I was thinking that you have to have something to stop that inertia, or you might if you don't design against that design, your chances go way down. But if you could stick something to the floor,
that's what I'm saying.
magnetically or
You could use something like that.
Suction cup,
you could use it as a defense.
That would be your bio
behind it.
mimicry, I guess.
Yeah. Also, it's consistent with the theme. Deep ocean
exactly,
theme.
exactly. Your octopus anchor.
Do you have any idea how many applicants there are, and then how many actual contestants? So, I mean, I wonder what percentage of people.
Right. So for season 1, it was closed. They basically invited previous participants. Season 2 probably be open. There'll probably be a lot of applicants. So one of the crucial things is just
getting in.
Do you know of any local competitors or other like SDSU fronting a team or some other colleges nearby?
I don't think many of the BattleBot teams are university based. There was the MIT team, but according to my friend, it wasn't an open club that anyone can just join. It was a very close group.
Well, how about you guys? Are you guys pretty much closed?
We're open to anyone that goes to UCSD.
You guys have mentors, or how does that work? Do you have anybody helping you out? Professors or anybody on staff?
We have a professor as an advisor, but in terms of machining, in terms of things like that, not so far. The university has some resources. We haven't really approached them yet, but if you know of anyone.
Yes. So when we are looking for sponsorship, it's not just money. We're looking for people to teach us a lot of things. We're looking for mentors. We're looking for a lot of other things, and
what's your deadline? When you gonna what do you have to present?
And it's designed by December.
Yeah, the design is probably around December, and then once we know, we'll start fabricating. Yeah. All right. Well, thank you so much.
Yeah.